Hello everyone, this is Gerhard Amemachoro from Ho Technical University Civil Engineering Department. So in this video, I'll be showing you guys how to solve a sample retaining wall question under Foundation Engineering using Geo5 software. So after opening your Geo5 folder, you'll be seeing a list of templates here which are also used for different purposes, but since we'll be using today's video for retaining wall, I'll be using the gravity wall template. So I'll double click on the template to load the template. So now, to begin with, as you can see, this is the workspace of the gravity wall template in Geo5, and we'll be making use of the tools at the right hand side of my screen. So these tools are the project, the settings, the geometry, the material, and the rest of the tools as you can see here. That's what we're making use of in order to do our verification of our retaining wall to know whether it will be satisfactory in terms of slip, overturning, and bearing capacity. So we go to project. When you head over to project, this particular section helps us to input project data such as our project name, the project path, the description, the client, the ATA, and different parameters under the project data. So with the settings, these help us to edit certain parameters of our work, or these help us to edit certain parameters regarding to our user defined template. So when we want to change a parameter, we head over to edit. When we click on edit, we see materials and standards, and as you can see, concrete structures will be calculated using the American code, but I'll be changing it to the British code, and the stone and masonry wall will also be governed by the Euro code, which I'll maintain as such. So from there we go to the wall analysis, where we are going to see the active pressure calculation will be using coulombs, the passive will also be using coulombs. And when we head over to the safety factor section, we'll see that the safety factor for overturning is 3, the safety factor for sliding is 1.5, and the safety factor for bearing capacity is also 3. But I'll be changing the safety factor for overturning to be 1.5. So after changing it and after editing anything within this set or within this section, you can now click on OK to proceed. So now the geometry of our retaining wall is what you can see in pink, and per the question given, the geometry of our retaining wall doesn't look like the geometry that is being given in the question. So in order to change the geometry of our retaining wall on our screen, what we do is we click on geometry and we select the suitable geometry that looks like the one we have in our question. So per what I have in my question, I'll be using the third one, which is here. So I'll click on it, and as you can see, the geometry also has some dimensions or some parameters which can be edited using the bottom section, as you can see here, which is the wall geometry, having from K1, K2, K3, K5, K6, S1, and S2. And now this section is very, I would say, is very tedious, but with consistency or with try and error, you try and you get everything here successfully. So after doing my try and error for some number of times, I've gotten my K1 to be 0.5, my K2 to be 5, my K3 to be 0.7, my K5 to be 0.4, my K6 to be 1.71, my S1 to be 8.5, and my S2 to be 1000. So after that, you guys can see I'm having a retaining wall with the same geometry but different parameters here. So as I said earlier, this particular section, which is the geometry section, needs a try and error part which has to be done for consistency, and after that consistency, you get to know your particular dimensions that you give your K1, your K2, your K3, and when you give those dimensions, you notice that you get the set of dimensions that will be given for your retaining wall. So from there we head over to the materials part. So the material part helps us to choose our material for our question, which is the retaining wall. So the unit weight of wall is 23 and the material of structure is concrete. So yes, this one, the material that will be used for our retaining wall is concrete, so we'll maintain the concrete, and the unit weight of our wall, since it's concrete, will be changed from 23 to 25 kilonewton per meter cube. From there, the characteristic strength of concrete that we'll be using in this video will be C30, so we'll be changing it from B25 to B30, and we'll click on OK, and the characteristic strength of steel we'll be maintaining is 250. So when you head to profile, the profile helps us to determine the depth of a particular layer of sand and its thickness. And per the question we are having one layer of profile, and this layer of profile covers from the top part of the retaining wall to the bottom part of the retaining wall, even going deeper below the base of the retaining wall. So here I can equally see the depth will be at 0 and the thickness of the layer will even go below the base of the retaining wall. So to add a profile, we click on add. The depth will be at 0, and when we come to thickness of layer, we change the thickness from 0 to, let's say, 8, which is also going below the base of the retaining wall. So after that, you can click on add. When you click on add, you can cancel, or you can add more if you want. So as you guys can see on my screen, my profile is starting from here, which is 0, and it's ending here, which is 8 meters, which is also below the base of our retaining wall. So from there we go on to add the swell and its parameters. So here we don't have any swell or any parameter of swell here, so we add a swell. So we click on add, and when we click on add, we get a pop-up menu of this. So the first thing is we give a name to the unit weight, to the angle of friction, to the cohesion of swell, to the internal friction, to the angle of friction of struct swell, and to the saturated unit weight. From there we give all these parameters of our swell and we proceed. So I'll give a name to my swell, let's say loosed sand, and the unit weight here is 19 kilonewtons per meter cube. The angle of friction is 36 degrees. They say it's cohesionless swell, but when you type in 0 in Geo5, the system responds not to pick it. So we type something close to 0, let's say 0.01, and for the angle of friction structure we also type 0.01. In the saturated unit weight of concrete, we add the unit weight of water to the unit weight of the swell here. So the 19 kilonewtons per meter cube, which is the unit weight of swell, we add it to the unit weight of water, which is 9.81, amounting to 28.81 kilonewtons per meter cube as our saturated unit weight. So after that, we add it to our system, and when we have any other swell, we add it. Apart from that, we cancel. So from here we can see that our profile is being generated on our screen, but if you guys can see, we are saying that what, no input or not input, which simply means that no swell has been what, assigned to this particular profile. So what we do is we click on assign, and after clicking on assign, you guys can see that the swell that we've given its parameters is now assigned to that particular profile. So from here we are good to go with our retaining wall and our sand and our swell. So with the right hand side of the screen, you guys can see we still have foundation, backfill, terrain, water, surcharge, FF resistance, applied forces, anchors, earthquake, siege settings, and the rest. But for now, in the question that we've been given, there is nothing pertaining to foundation, backfill, terrain, water, surcharge and the rest. So for now, we won't be touching all this set, but rather we'll be jumping to verification in order to verify whether our retaining wall is suitable for this particular soil. So when we click on verification, we can see that's what our retaining wall is satisfactory in terms of overturning and in terms of slip. So to see a detailed answer, you can equally click here, which is in detail. As you can see, we are having resisting moment, overturning moment, and we are having what active horizontal force. So you can see the particular answers that we've been gotten here in order to know whether truly our wall has been satisfactory for overturning and for slip. So since we used the columns to do it earlier as we did at the settings, I also did a manual calculation using the Rankine's theory, and for the resisting moment we are having 576.88 kilonewton meter per meter, but after the manual calculation using Rankine I had 577.386. so you guys can see that the difference is also negligible, which is showing us that we are right on track. The overturning moment we also have here is 152.13, and after my manual calculation I've also gotten 152.475, and as you guys can also see, the difference is also negligible. So for slip, you guys can see that the active horizontal force is 79.86, and for my manual calculation, my slip for active horizontal force is 80.25. So with this, we can also confirm that it is not just that our retaining wall is satisfactory for overturning and for slip, but also it is corresponding with the same thing that I've done using Rankine's theory. So from here we close. So after closing, we go and check whether our retaining wall is satisfactory in terms of bearing capacity. So what we do next is to come down, scroll to the bottom, we see bearing capacity, we click on bearing capacity, and as you can see, the eccentricity of our retaining wall is correct or is satisfactory, but the foundation or the bearing capacity of the soil is not satisfactory. So the reason why our foundation soil or our bearing capacity is not satisfactory is because we didn't give an ultimate bearing capacity of the soil in the template. So now we are coming to input it, and per the question, the ultimate bearing capacity of the soil is 1800 kilopascal. So I input 1800 kilopascal, and after hitting on enter, you guys can see that what the bearing capacity of the soil is also satisfactory. So now the same way, if you want to see an in-depth of the calculation, you can also click here and you see in detail, which shows us that what truly our soil also passed the bearing capacity test. So we close, and from here we move on to stability, and after moving to stability, a new page pops up, and here is where we do the analyzation. So doing the analyzation, we walk through to the analyze here at the right side of my screen, and we see analysis. We click on analysis, and as you guys can see, the analysis is ready to be done. So to analyze this particular retaining wall under these soil conditions, we have the analyze button here at my left side. So I click on it, and as you can see, the FS Bishop is running the analysis for the retaining wall. So after some series of analysis, we can now conclude that what this retaining wall has also passed the slope stability test. So they can also tell us that what the factor of safety for our slope stability is 1.7, which is greater than 1.5. So therefore our slope stability is also acceptable for this. So this is how we check or we verify for retaining wall with a given parameter of soil. So this is what I've done for now. Thank you.